Hello, Algebra 1. We are going to go over your homework today and learn about parallel and perpendicular lines, and then I'm going to tell you that you're going to have a quiz on the next time I see you, which should be Friday. So, first off, make sure you have done your homework. Make sure you have shown whoever is there for me today that you've done your homework. And we are going to get started with homework number 6. So you only had to do numbers 1 and 2 on homework number 6. We are using the formula y equals y1, or your y coordinate is equal to your slope times x minus your x coordinate. And remember, your first point in your ordered pair is your x and your second point is your y. So you're just substituting in these numbers. You have y minus 2 equals your slope of 3 times x minus your x point, which is, or your x coordinate, which is 4. And then we want this to end up being in slope-intercept form, so we're going to solve for y. First we have to distribute over on this side, or simplify over here, so we're going to do 3 times x is 3x, and 3 times negative 4 is negative 12. And then we're going to add 2 to each side, and we end up with y equals 3x minus 10. And that is your final answer. That is your equation in slope-intercept form. You're going to do the same exact thing over here on this side. And so you have your x point, your y part of your point, your slope. You substitute in all your values. I'm not going to work the whole thing out for you. Hopefully you got y equals negative 2x plus 3. If you did not, go ahead and pause the video and look at your friends' stuff next to you and see if they got it correct, and if they did, compare your work and see where you went wrong. Okay? And if you have any questions on any of this at any point, just make sure you email me so that I can get back to you and help you out with what you need. So that was homework number 6. Homework number 7, you also only had to do number 1 and 2, so make sure you show that to whoever is in for me today. And let's take a look at the first 2 of those. So we are doing the same thing, except, so we're still doing y minus y1 equals m times x minus x1, except for in this case, they haven't given us a slope. They've given us 2 points. So the first thing we have to do is find out what our m actually is. And we're going to just decide which point we're going to write down first. And we are going to write down the first one first, because that's easiest. We need to remember that slope is the change in y over the change in x. So our ordered pair is xy, but our slope is y over x. So we're going to do negative 2 minus 0. And then we're going to do negative 4 minus 4. Negative 2 minus 0 is negative 2. Negative 4 minus 4 more is negative 8. And that reduces, negative divided by a negative is a positive, and 2 over 8 is 1 over 4. Remember, you can always put this in your calculator also to double check yourself to make sure you're on the right track. So now we know that our slope is 1/4. So we can substitute that in. Our x point, we're just going to still use, you can use either of these points. I'm just going to use the one that I already have circled, just so I don't get confused. So I'll have x minus negative 4. I should use brackets there, I guess. That's okay. And then y minus my y point, which was negative 2, which y minus negative 2 is y plus 2, and x minus negative 4 is x plus 4. Then, if we distribute this, we end up with y plus 2 equals 1/4 x, and then 1/4 times 4 is just 1, so that's plus 1. We're going to subtract 2 from each side, and we end up with y equals 1/4 x minus 1. So that is your equation in slope-intercept form. On these, if you're getting a fraction over here, you probably did something wrong. It is possible to get a fraction, but they're going to give you nice clean numbers to work with. So you can have a fraction here where your slope is for your m value, but they're not going to give you, I don't suspect that they're going to give you any fractions over on this side. If they did, I would let you know in advance, and I'm not seeing any. All right, I'm not going to do all the steps on this one. Same thing though, you solve for your slope first, then you use your equation, you substitute in your values, and you should end up with y equals -1/3 x plus 5. Make sure you're not forgetting your x here whenever you're writing your slope-intercept form. And again, if you missed that, just compare with a neighbor and see what happened. Then, homework number 8, you were supposed to do all of. Before that, we had gone over one of each of these. So if you need to review this, this is a valuable piece of information for you. You are going to be having a quiz the next time I see you, and it's going to be on all of this. So you want to be reviewing this. Homework number 8 is a review of all of that. So make sure you have been working on these. And make sure that you have these answers correct. Obviously, you should have been working on these. You should make sure you show whoever's in for me that you did this one also. But make sure you have the answers written down correct. And if you miss any, make sure you redo them, because this is basically your quiz. Plus what we're going to learn today. So this is like the perfect review for your quiz. This is what it's going to look like. You're going to have some of each of these problems on your quiz. So for all of these, we're writing an equation in slope-intercept form. That is our goal here. Write your equation in slope-intercept form. So here they just give you your slope and they give you your y-intercept. If we need to, we can remember that slope-intercept form is y equals mx plus b, where m is your slope and b is your y-intercept. So they're giving you your slope and your y-intercept. So you just substitute those two things into this equation. You should have y equals 2/7 x. If you wanted to, you could write plus 0, but it's not necessary. The next one should be y equals x minus 4. If you had 1x minus 4, that's not wrong. It's just not necessary. Number 3, we look at, you should write little notes over the side, like write out what is your slope, what is your y-intercept, so that I know you know what you're talking about. So here our y-intercept is this point. It's where it's crossing our y-axis. Remember, this is the y-axis and this is the x-axis. So this is at -2. So we have a y-intercept of -2. And we have a slope of, we're going to go from one point to the next. So we go up first, because slope is rise over run. So it's 1, 2, 3, and then over 1, 2, 3, 4. So this is 3/4. Remember, if you're going on along and you go uphill, this is a positive slope. So this, make sure you have a positive 3/4. So just like we did on 1 and 2, we use our slope and our y-intercept. We substitute it into our equation, and we end up with y equals 3/4 x, and since this is a -2, we just write down -2. Next one, our slope and our y-intercept. We write those out. This is a y-intercept at -1. Our slope, we go down 2/2, so 2/2 is 1. And this is, we're going on along and we go downhill, so this is a negative slope, so make sure you're giving me a -1. And then just sub in those values. So we have y equals -x, or you could have -1x minus 1. Okay. On the next set, these are in standard form, and we need them to be in slope-intercept form. So we're just going to solve for y on each of these. First thing we do is move our x term over, so we subtract our 2x term. And then I rewrite it so that my x term is first. So since we subtracted it, it's a -2x, and this was a positive 35, so I write down plus 35. And then to get y all by itself, we need to divide each term by 5, so we end up with y equals negative 2 over 5x plus 7. We're going to follow that same pattern for the next 3. So here are your answers. You should have y equals 2x minus 4. Then y equals 1/6 x plus 5. And y equals 5/4 x plus 3. If you missed any of those, make sure you pause the video and check with a friend and compare notes and see where you went wrong. Now 9, 10, 11, and 12 are just like we did. This was homework number 6, and this was homework number 7. So if you need to see the steps on how to work those out, you can refer back to those. I'm just going to give you the answers. So for number 9, you should have y equals 5 over 2x, and for 5 over 2x plus 2. And for number 10, you should have y equals negative 3x plus 2. For number 11, y equals negative 3 over 2x plus 2. And y equals negative x, or you could have negative 1x minus 6. Okay, so there are all your answers for this one. Make sure you have these written down. Make sure you have gotten them correct. And if you did not get them correct, make sure you redo them, because this is what is on your quiz. Okay, on that note, we are going to start something new today, which is parallel and perpendicular lines. Let's see, we're at the 11:45 mark, in case you need to skip to there. I'll write that down. So, parallel lines are lines that never intersect. Which means they have the same slope. So that's the key. Same slope for parallel lines. An example, y equals 2x plus 1, y equals 2x minus 7. Okay, if we were to graph these two lines, you have one crossing at 1, and then you're going up 2 over 1, up 2 over 1. So here's one line. And then here is one crossing at negative 7, so it'd be down here somewhere, but you're still going up 2 over 1, up 2 over 1, and you're drawing in your line, and you notice that they are always the same distance away from each other, to the best of my ability in drawing that, and they will never touch. They will always keep going up 2 over 1. They'll never get any closer to each other. So those are parallel lines. Perpendicular lines are lines that intersect at 90-degree angles. These lines have negative reciprocal slopes. Negative means opposite. So it's both of these things. Not just one or the other. They have to be a negative or positive. So if it was negative, it's going to be positive. If it was positive, it's going to be negative. That's why we said opposite. And it has to be reciprocal. So example, y equals 2x plus 1, and y equals negative, because this was positive, so this is negative, and this was 2, so instead of 2, this is going to be 1/2 x. and then in this case they have plus 5. But this is the part we're looking at. We're looking at the 2, and we're looking at the negative, so positive to negative and 2 to 1/2, because this would be 2 over 1, so now it's 1/2. It's kind of a little tricky. Well, let's just do our best with this. So we have 1 crossing at 1, and you're going up 2 over 1, up 2 over 1, so that's the best I can do on that line. And then here's 1 crossing at 5, so 2, 3, maybe like about there. And this one is down 1 over 2, down 1 over 2, down 1 over 2. So it's about, that's kind of the best I can do without having a grid and a ruler. But you can see that they cross at a 90-degree angle. So what are negative reciprocals? So remember, negative just means opposite. So if it was negative, it's going to be positive, and if it was positive, it's going to be negative. And then reciprocal is the flip of a fraction. So this was positive, so it is going to now be negative. This was 3 over 4, so now it's going to be 4 over 3. This is the negative reciprocal of 3/4. So what is the negative reciprocal of positive 2? Well, we just did that one up here. It was positive, so now it's going to be negative. It was 2, or 2 over 1, so now it's going to be 1 over 2. This one was negative, so now it's going to be positive, and it was 7 over 8, so now it's going to be 8 over 7. This one was 1, or that's 1 over 1. So it was positive, now it's going to be negative, and it was 1 over 1, and believe it or not, this one is still 1 over 1, because that is the reciprocal. And then 0. Let's just think about this one for a second. If this is an example of our perpendicular lines, and this is a slope of 0, then the negative reciprocal is going to be this, which is a slope which is undefined. So 0 and undefined are their opposites. Okay, so if it was undefined, it's going to be 0. If it was 0, it's going to be undefined. And if you just kind of like picture that in your head, it makes sense because we know this is a 0 slope and this is an undefined slope. So it says determine if segments AB and CD are parallel. So segments are just lines. Determine if they are parallel, perpendicular, or neither. So to do this, we need to know what their slopes are, because whenever we talk about parallel and perpendicular, they either have to have the same slope to be parallel, they have to have opposite reciprocal slopes to be perpendicular, or if it doesn't fit either of those, then we're going to have an answer of neither, which means we're going to have to find out what the slopes of these lines are. So we're going to label this line segment AB. That little line on top of there means it's a line segment. So line segment AB, and we're going to find the slope. So remember x and y. Slope is the change in y over the change in x. So we're going to do our y's first. So 3 minus 6 over negative 2 minus 2. This is, let's see, negative 3 over negative 4, which is negative over a negative is a positive, so the slope of line segment AB is 3/4. Then when we do line segment CD, we find the slope of this one. It's going to be 0 minus 3 over negative 1 minus 3, which is negative 3 over negative 4, which again is 3/4. So we have a slope of 3/4 and a slope of 3/4, and since our slopes are the same, these lines are parallel. Okay, let's try number 2. So we have another set of lines. We have lines AB and lines CD. We're finding their slopes. First one, remember we're going to keep these separate. So we have 0 over 2 and 5 over, or 0, 2, 5, 4. Those are our points. So we have our y's. We have 2 minus 4. And then we have 0 minus 5, which is negative 2 over negative 5, which is positive 2/5. Then for this one, we have 8 minus 3 and 1 minus 3. By the way, if you need to color code these or something to keep them separate, because I know there's a lot going on up here, go ahead and do whatever you need to do to organize these. So we have 8 minus 3 is 5, and 1 minus 3 is negative 2. We have a positive divided by a negative, which is going to give me a negative, and this is 5 over 2. So in this case, I have a positive 2 over 5, and then a negative reciprocal, which is 5 over 2. So these lines are perpendicular. Okay, next one. Go ahead and find your slopes. So we have 8 minus 6 and negative 1 minus 2, which is 2 over negative 3. So that ends up being negative 2/3. Then for this one, we have 2 minus 3 over negative 1 minus 3, which is negative 1 over negative 4, which would be positive 1/4. These are not related to each other in any way. So these are neither. I could make you find the slopes on these last two, but I'm just going to tell you what they are. We have AB's, or line segment AB's slope is negative 1/3, and line segment's slope is 3. So remember, 3 is the same thing as 3 over 1. In this case, we had a negative 1/3, and then we have a positive reciprocal of 1/3. So because they are opposites and they are reciprocals, this makes these lines perpendicular. Okay. 5, 6, 7, and 8 on the next page. Just continue on with those. I'm not going to make you do those right now. I think we've gone through enough examples, but if you would like some more, they are there. Then 9 through the rest talk about how we figure it out with an equation. So these are actually easier because the slope is given to us. We just need to remember that slope-intercept form is y equals mx plus b, where m is our slope. So all we have to do is look at the slope on these. Here we have a slope of 7 and a slope of 7. Since these slopes are the same, we know that these lines are parallel. Here we have a slope of 4/5, and then, so this was positive, this one's negative, this was 4 over 5, this one's 5 over 4, so these are opposite reciprocals. And because they're opposite reciprocals, these are perpendicular lines. Here we have a negative 1/3 and a positive 1/3, so they are opposites, but they are not reciprocals. And they are both 1/3, but one is negative, one is positive, so they are not the same, which means that these are neither. So they have to check all the boxes. They either have to be exactly the same or they have to be opposite and reciprocal. If they're not, then they're neither. All right. Then what happened? They gave us standard form, which means we're going to have to change them into slope-intercept form and then compare them. So we need to solve for y, so we'll subtract our x from both sides on this one. We end up with 6y equals negative x plus 30. Divide each term by 6, and we end up with y equals negative 1/6 x plus 5. On this one, we're going to do the same thing. So we're going to move our 3y over. Oh, no, the y is already by itself, sorry. We're just going to divide each term by 3. We end up with y equals, let's see, 18 divided by 3 is 6x, and then minus 6 divided by 3 is 2. So here are our slope-intercept forms. We just need to focus in on the slopes. So 1/6 and 6 are reciprocals, and we've got a negative and a positive, so they are opposite reciprocals, so these are perpendicular. Finally, I think you're probably catching on to these, hopefully. If not, email me and let me know. But they're all, basically the same thing. Make sure they're in slope-intercept form, compare the slopes, tell me if they're the same, opposite reciprocals, or nothing. 16 is the only one that's a little bit different, but if we recall, if we were to graph these, when you have y equals 6, that means I'm going to be going up 6, and my y is always going to be 6, so here I have a horizontal line. Then if I have x equals -1, that means I'm going to go over -1, and everywhere on this line is always going to be over -1. So I have a vertical line. Also, that means this is a slope of 0, and this is an undefined slope, which means these are perpendicular lines. Okay. I know that was kind of like straight through, kind of quick, no discussion in between, but hey, that's because I'm not there. If you have any questions on these, let me know. You will have homework on these, but we're also going to move on to the next lesson, which is writing parallel and perpendicular equations. So this is page 38 in your packet. So what are we doing? Given a linear equation and a certain point, you can create another equation that passes through this point and is either parallel or perpendicular to the same given line. Keep in mind the following points. So keep in mind these things, like not points on a graph, like points, bullet points, things to remember. Parallel lines, we already said, and we need to just remember, parallel lines have the same slope, and perpendicular lines have negative reciprocal, but I prefer to call them opposite. So negative is a technical term, but we've been calling them opposite reciprocal slopes. Okay, so basically they're giving us a line. So this is the line they're giving us. They're wanting us to give an equation for another line. So write an equation for another line. And in this case, we're going to give another line that is parallel. So because they're giving us a point to go off of, we are going to have to use point-slope form. And point-slope form was y minus y1 equals your slope times x minus x1. Point slope form, you use the slope, and you use a point. That's why it's called point slope form, because you can use a point, the x and the y, and you can use a slope, and that'll give you your formula or it'll give you your equation in slope-intercept form whenever you're all done. So here's our point that we're going to use. That's good enough. We've got a point, but now we need the slope for point slope form. And since it's going to be a parallel line, we know the slope has to be the same as what was given. So our slope is going to be -4. So then we just use our point slope formula. We say y minus the y part of our point, which is 7, equals the slope, which is going to be the same, so -4, times x minus -2. So minus -2 is the same thing as, I'm just going to write down plus 2. And then we're going to change this to slope-intercept form, and that'll be it. So we distribute, we get -4x, and then -4 times 2 is -8. We add 7 to both sides. We end up with y equals -4x minus 1. Okay. Same thing again. We'll do another one. They want us to write a line, or write an equation for a line that is parallel given this point. So we're going to use point slope form, and the slope is going to have to be the same as this line. First, we're going to have to find out what this slope is, though, because this is in standard form. So we're going to subtract x from both sides. We end up with -3y equals -x plus 9. We divide everything, each term, by -3, and we get y equals negative divided by negative is positive, so that's 1/3 x, and then positive divided by negative is negative, so -3 or -3. So we have y equals 1/3 x minus 3. So this is all stuff we've done before. It's just kind of like remembering where we are in the process and what we need to do next. So we found the slope of this line. The slope of this line is 1/3. We're writing an equation for a parallel line, so it has to be the same slope, so we're using 1/3. And then we're going to use our point slope formula, because now we have a point and the slope. So we have y minus our y point, which is going to be -1, and y minus -1 is y plus 1, equals our slope of 1/3 times x minus our x point, which is 3. Okay, we distribute. So we get 1/3 x, and then 1/3 times -3 is -1 or -1. Then to get y all by itself, we're going to subtract 1 from each side. So we end up with y equals 1/3 x plus 2. And this is a line that would be parallel to this line. Always make sure you double check if they're parallel, that this slope and the slope that we got over here need to definitely be the same. Okay? Same idea, except we're now going to write the equation for a line that is perpendicular to this line. Perpendicular means they have to be opposite reciprocal slopes. So if this slope was 2, our opposite reciprocal slope is going to be, this was positive, this is going to be negative, this was 2, so this is going to be 1/2. So this is the information we're using to write the equation for our line that's perpendicular. So y minus our y point, which is 3, equals our slope, which is -1/2, times x minus our x point, which was 4. We're going to distribute 1/2 times 4, and negative times a negative is a positive, and half of 4 is 2. Then we're going to add 3 to both sides. We end up with y equals negative 1/2 x plus 5. Okay, whoever's there, go ahead. Well, we'll do one more together. Then I'll have you do a couple by yourselves. So once again, we need to know what the slope is to be able to do this. But this is in standard form, so first we have to put this in slope-intercept form so that we can find out what the slope of this is. So we are going to subtract our x term from both sides. We're going to divide each term by 3. And we find out this is our line, this is the line we know, which had a slope of negative 5/3. So we need to have the opposite reciprocal. So if this was negative, ours is going to be positive, and if this was 5/3, ours is going to be 3/5. So this is the information we're using to write the equation for our line that is perpendicular to this one. So we do y minus our y point, which is 1, equals our slope, which is 3/5, times x minus our x point, which is negative 5, and minus a negative 5 is the same thing as plus 5. Then we distribute. Let's see, 3/5 times 5 is just going to be 3. Remember, we're just cross-canceling if you're doing that in your head, or you're going to put that in your calculator, 3/5 times 5. Make sure you're not adding these. It's 3/5 times 5. And then we are going to add 1 to each side, and we get y equals 3/5 x plus 4. Okay, so on that note, the next page is more practice. I'm going to have you do let's do 2 of each. So why don't you do 5, 7, 9, and 11? So you're going to do page 39, 5, 7, 9, and 11. You have whoever's there, pause the video, finish those, compare them with the person next to you, take like, I don't know, 5-10 minutes to do these, and then push play and you can check your answers, and then I will give you your homework. Okay, here we are. I wrote down the answers for 6, 8, 10, and 12 just in case you'd decided to do those too. However, here are the answers for 5, 7, 9, and 11. I'll go over them, not step by step, but I'll at least walk you through them. So for 5 and 7, they wanted parallel lines, so you had to use the same slope. So the slope was 2, you're also using 2. You're using your point and your slope in your point-slope formula, and solved it out, and you have your line's equation is y equals 2x plus 7. For number 7, you had to change your standard form into slope-intercept form. You should end up with a slope of 1/2. So you use a slope of 1/2 because you're writing the equation for a line that is parallel to this one. And that is your point that you're using. You use that in your point-slope formula, solve it out, and you get your line's equation is y equals 1/2 x plus 3. Then for number 9 and 11, these were supposed to be perpendicular lines. So they gave you this line. Your line needs to be perpendicular to it. So they gave you a line with a slope of 3/4. Yours needs to be the opposite reciprocal, so you should be using a slope of negative 4/3. There's the point you're using. You sub that all in, you solve it out, and your line's equation should be y equals negative 4/3 x plus 1. Then for number 11, you should have, this is in standard form, so you have to change it to slope-intercept form. You find out the slope of this line is negative 1/5 x. you need to have a slope that is an opposite reciprocal in order for your line to be perpendicular. So you're using a slope of 5, and there's the point they gave you to use. So you sub that all in. That's y minus 3. I messed up there. But it should be y minus 3. You solve it all out, and you should have your line's equation is y equals 5x minus 7. Then, right now, really quick, I would like you to go back to 36 and do this with a partner. All you're doing is, you don't have to do the whole coloring part unless you really want to. I just want you to look at them and tell me whether they are parallel, perpendicular, or neither. So you can work with someone to complete that. I would like you to show that to whoever is here before you leave. Also, if you don't want to write out the words parallel, perpendicular, or neither, you could just draw the symbols for them. And we haven't gone over what the symbols are, so I'm going to tell you what they are in just a second. So the symbol for parallel lines is like the two L's in parallel. It is this right here. You just draw two straight up and down lines. Then for perpendicular, you draw, it's basically like an upside down capital T. I kind of wrote those on an angle. They should be straight up and down. And then for neither, you can just do N. So for instance, the first set has the same slope, and if I were you, you can just circle those so you know what you're talking about, and I know you know what you're talking about. Same slope means that they are parallel lines, so they are parallel. The next one, you have a slope of -2/5 and positive 2/5, and even though they are opposites, they're not reciprocals and they're not the same, so this is neither. And the last one on this line is -1/4 compared to 4, so it's negative versus positive and reciprocals, so they are opposite reciprocals, so these are perpendicular. So you just do that. Unless, of course, you don't know what the symbols are, and then you should write parallel and perpendicular or neither out. So finish that with a partner. But then also, I'm going to tell you what your homework assignment is, so that if you finish this and you have time, you can start on your homework. So let me write that out on here. Or maybe it'd be easier if you just go along and circle them. Let's see here. So for homework number 9, let me find my page with homework number 9. Here it is. You are going to do 2, 4, 6, 7, 8, 10, and 12. I know that seems like a lot. Well, it's not really. It's 7 problems, but I need you to have an example of each. So this is on page 37, in case you can't find where it is. Homework number 9, page 37, you are doing 2, 4, then 6, 7, 8, so that's 6 through 8, and then 10 and 12. So that's for homework number 9. Homework number 10, which is on another page that I have to flip around and find. Page 40. You are going to do 2, 4, 6, 8, 10, and 12. So that's just the even ones. So 2, 4, 6, 8, 10, 12. And then, this is why I already had you do homework number 8 last time we were together. You are going to review homework number 8 because now you already have the correct answers for it because that is part of your quiz. And you have a quiz on the next day I see you, which is going to hopefully be Friday. And that will cover everything on homework 8, homework 9, and homework number 10. So email me if you have any questions, or see me tomorrow because hopefully I will be back by then. And you are also working on, right now, page number 36 with a partner in class, which is just looking at them. Some of them you have to change from standard to slope-intercept form. but you should be good. You should probably have another, I don't know, 20 minutes, half hour left to do this with a partner. Make sure you show whoever's in with me so they can check it off that you have completed it. You have to do that before you leave. And then we will go over all of that. I will, if you pause this video, I will have the answers to page number 36 so you can check them before you leave so that you know that you are correct. But otherwise, that's all I have for you today. I hope you have a lovely day, and I will see you on Friday. And there are your final answers to check. Okay. Okay, bye.